Can you hear it? The Pulsar circuit is alive. What we have occurring here is our highly efficient Pulsar circuit, which still gives off minor amounts of wireless power, is being run by an input supercap here. So we have an input supercap, and it's only drawing 2 watts. There's an analog voltage meter on it, and we're almost at a full charge on the input supercap. Powers up the ringer. The ringer output goes through a full bridge rectifier, which is like 26 or 28 volts. Charges up a big capacitor bank, big cap bank, then dumps through a timing circuit into this supercap. And from that supercap we then power up an inverter that runs the load. So, and you can actually see the load flickering with each pulse. Maybe you can hear that. So yeah, that's pretty simple. To sum it up, input cap, 14 volts, goes through a little bit of a voltage reducer, turns it to 9 volts, powers up the Pulsar circuit, which also gives off wireless power. And that wireless power, well, that power then goes through a full bridge rectifier, charges up big capacitor bank, goes through a timer circuit. We then pulse discharge that. You can hear it ticking. Pulse discharge that into another big cap that we then use an inverter for to run our 120 volt AC load. So, as you can see, that's a 40 watt load, and each time it pulses, it fights the voltage drop on the big capacitor. Hopefully I can get a better view of that and you can see that meter. So we are fighting the voltage drop with the pulse. And then it actually gets slightly brighter. I'll unscrew it, show you the bulb. This is a pure sine inverter, 350 watts I believe, and that bulb is very hot. There's our meter. Almost at a full charge again on that cap. So the high frequency from the Pulsar circuit almost instantly recharges the super cap. Again, I'll hook up an LED. I don't even know what this, it's an LED floodlight. Yeah, it draws 9 watts. A lot less than that 40 watt incandescent. So I'll plug that in, full intensity. And our Pulsar circuit fights the voltage drop. You can't even see it noticeably. Yeah, you can't even see it. We're hardly drawing any power. But you see it more when I connect a incandescent load. So here's another incandescent load. I like it when they actually say what's on it, like this one. 40 watt 120 volt AC incandescent load. I'll connect that in. And for those who think there's something weird going on under here, there's not, so there's nothing under the desk. Completely clean setup. Again, what we got powering it, super cap. Again, we're not even really draining anything. It's the Pulsar circuit, baby. You can see us fighting that voltage drop with our Pulsar circuit. It's fighting the I can turn this a little. Yeah, each pulse we're fighting the voltage drop. I actually see it get brighter when the pulse goes off. Probably run a bank of those lights and still fight the voltage drop. As you see, we don't want to drop below the full charge. Hopefully you can hear that high frequency ringing. Now I'll disconnect the load, which is extremely hot. And as you see, we're almost at, we're at full charge. Full charge on the output cap when load is disconnected. Source is still at a full charge. And again, to sum it up, voltage meter, analog voltage meter on the input supercap. Input supercap gets reduced from 14 or 15 volts DC to 9 volts DC, which will not blow the circuit. Have a highly efficient large switching transistor. It goes through the pulsar circuit. There's a primary and secondary wound on a nano crystalline ferrite rod core, which has some type of negative resistance effect. We then take the output of that, which is like 30-40 volts, and then we rectify it through a high-speed, fast-switching full-bridge rectifier, 1N5408. Charged up a big capacitor bank. Big capacitor bank, because it's high frequency, will rapidly recharge. We then pulse dump it with our timing circuit into this other capacitor that then runs the load. And as you see, we're at full charge. I can connect my load again. It's working, no problem. This setup is a lot more efficient and simpler than that big transmitter. That kind of reduced to that. It shrunk, it got more refined. So yeah, you can hear the thing pulsing away happy. You can also use this output to charge a large battery bank and then recycle the energy in the system, keep it going, and do whatever you want. So it's literally called the Pulsar circuit, or the ringer, whatever you choose to call it. It's extremely simple. Can't really see much because there's a glare there. But yeah, the high frequency rapidly recharges our DC cap bank that then pulse dumps into here. Also, if you earth ground the negative of the capacitors, they will charge quicker. So it should make the pulsar circuit more efficient just by earth grounding the negative of the caps. It should charge up quicker. As you can see, you can really see the difference now when you earth ground it. Still full charge. No degradation on charge in the supercap. And that's an analog voltmeter. It's not prone to interference, so connect the load back up again. 40 watt incandescent, throwing off heat. Fights the voltage drop with each pulse. There's the charge on the input. We don't draw more than 2 watts. And again, you could use this output to recharge big battery banks quickly, recycle the energy as long as you have that earth ground or a large negative plate. And yeah, that's that. I'll disconnect it. You can see more of it right there. Still full charge. And that's a 40 watt bulb. Here's what the inverter looks like. I don't want to accidentally short this out somehow, but there's nothing fishy underneath it. It is a pure sine wave inverter. 350 watt. High quality one. And again, here's another bulb. Incandescent type. I believe he's 40 watt too. So, this is the real part of the circuit that does the real work. You see those cap pulses fight the voltage draw that this creates. That cap bank pulse is fighting the voltage drop. You can see the needle move with each pulse. And yeah, that's the correct way to use this type of power, because the high frequency rapidly recharges your cap bank, your DC cap bank, and you dump it into another cap that acts as your buffer tank that then runs your AC load. and you earth ground the negative of your cap bank right here with that green wire. You set up a negative potential so they'll recharge even quicker. You can really see the heavier the load you put on it, the more dramatic you'll see the voltage drop being fought with each pulse. The thing is, I don't want to put too big of a load here because I might melt the wires. And if I disconnect this, the thing would obviously recharge itself back to full right there, very rapidly. And our cap dump fires for 0.1 seconds every 2 seconds. And it's probably dumping 20 or 30 amps at 14 volts into this super cap. And sometimes you see the wires twitch. There's so much current going through. So that's that. And there's the input. It's almost like we're getting into the point where we're using high voltage electrostatics from the efficient circuitry to rapidly recharge DC cap banks once it's earth grounded, to then pulse that with a special timing circuit. That's very important. We pulse dump that into here, our other super cap, that then runs your load, no problem. Again, you can see it fighting the voltage drop. So that's that. I'll do a quick tour of it. I'll back up. See everything going on here. These are just some Pulsar modules I was experimenting with, not in use in any way. So that's what we got right here. You can see the bulb flashing with each pulse. So here's underneath the desk. There's nothing underneath the desks. There's our bulb. There's our ground connection. Here's the excess accumulated radiant energy too in the system. And I'm going to have to bring this outside and do tests with it outside. Imagine constructing a large antenna or having a very deep earth connection would cause it to extract more energy. Here you can see all the radiant energy that's present on one of the coils of the Pulsar circuit. Again, there's our input supercap. Not really dropping in charge because we're drawing such a little amount. I have very efficient components here. Nice 40-watt load, no issue. Still have radiant energy present even on the 40-watt AC load here from the Pulsar circuit. There's a radiant energy effect that's very difficult to get rid of, even with isolation circuitry. It's kind of annoying. I haven't quite figured out how to get rid of that. As you see, we're still fighting the VI drop, or the voltage drop. And again, this would probably run this for a few hours before that died. But the point is, you would charge a big battery with this, have excess energy, and then keep the system going, and always have a small gain, as long as you have that earth connection connected. And there we go. Now we're pretty much full charged again. So figured I'd show that. Feel free to like, subscribe, support the Patreon if you want. There's not just on the Patreon, we have a whole bunch of knowledge regarding electrical engineering. It's all free, all compiled on my website. Feel free to check it out. But yeah, the Pulsar circuit, very energy efficient. You earth ground it, especially with a large capacitor bank. Maybe that's where people went wrong. You need a huge capacitor bank to get the excess power, and you ground the negative. So I don't think anyone spent $200 or $300 on capacitors, big DC ones, to actually get some real work done with this type of stuff. So that's how that works. Feel free to like, comment, subscribe. The only most expensive parts in this circuit are the inverter, all those DC caps. That was dirt cheap, the timing circuitry. Diodes are cheap. Heatsink obviously cheap. The transistor, not too expensive. that special nano crystalline core the transformer is wound on, which gives negative resistance. A little pricey, about 15 bucks a rod, but definitely worth it if you want negative resistance. And again, there's the results. I'm not sure if you can hear the high frequency pulsing in the video, but anyway, that's how it works. Yeah, that's that. So I also sell that transmitter as a kit. I'll be selling the Pulsar circuitry as a kit. Not sure on the exact price yet. And I also sell these advanced crystal power cells as a kit. This thing has been running these lights since I built it. If the light ever gets dim, you just add a drop of water to each cell. So yeah, a lot of interesting stuff going on. So we sell crystal power cells. Patreon members get a discount. We sell the transmission circuit, the highly efficient Tesla transmitter circuit, the monopole transmitter. Energy sloshes back and forth between the bucking coils, and you get highly efficient radiant energy transfer. We will very soon be selling the Pulsar circuit, and I might even do a huge massive kit that includes the inverter, the light, the super caps, maybe the analog voltage meters. It'll set you up and off running, and whatever you do with this, you can do with your heart's content with it. So yeah, again, we'll take a step back and just admire it. I'm going to try and keep this video under 20 minutes. Just take a good look around everything. These aren't being used in any way. That's the power source for the transmitter when I want to hook it up and turn it on. So you don't have anything coming from the wall, nothing is on. This is all a self-contained system. Here's a good look at the caps. And yeah, you're witnessing the result of years of work bearing their fruit. So, pretty cool, huh? Almost no drain. Now you get any battery in the market or any supercapacitor in the market, and you try and run a regular 40-watt load off that without draining anything. Better yet, I'll even put this here so you cannot argue it's not a 40-watt load, because that doesn't show the wattage. This one does. Now you can't argue that it's not a 40-watt load. So find me any battery that size, any supercap that size that can do that without draining, or draining extremely slow. And the moment I disconnect it, it will recharge. So that's that. And again, I can just take this, want some light, so clean it up a bit so you can see a bit better. So yeah, I just, the setup got a little bit too long, so I needed some more desk room. I think the video's gone on long enough and you get the point. Kind of a glare there. I really see it pulsing. If I back up at a distance, you can see it. That's why I call it the Pulsar. So yeah, that's all I got to show, and feel free to like, comment, subscribe, join the channel, join the Patreon. Even if you're not a paid supporter, we still have a compendium of electrical knowledge condensed for free on the Patreon, all in one spot, that will teach you so many things. It took electrical literature, both ancient and modern, combined it all in one spot so you don't have to spend hours searching for it. So, that's that. Disconnect, and there's heat from that. There's a lot of heat. And we're pretty much no degradation on charge once you disconnect. Here's the input. And we still have radiant energy pulses. The key was decoupling caused from effect with this thing, and grounding the caps here. You don't want to touch that. So yeah, that's that. And feel free to like, comment, subscribe.